Bismillahirrahmanirrahim. This we discuss about the merge sort. And the merge sort is a very powerful sorting technique which uses the divide and conquer paradigm. It basically does what? It divides the first one thing is which breaks this partitions this list into the sub lists and then merge them together. So let's see how to do it. Let's do it in a reverse order. 8 7 6 5 4 3 2 1. This is my, for example, the array which has the 8 elements. So what it does is first is the partitions into the 2, so that will be 8 7 6 and 5, and then 4 3 2 and 1. Okay. Now what it does to it is what it does to the sublists. So first it divides the 2, okay, and then it merges, right? How it merges is it initializes, it calculates the mid of this. For example, calculates the mid, because this is, if this is my array, it calculates the mid. That's gonna be the 4 here, because I gotta say 0 1 2 3 4 5 6 and 7. 7 plus 0 divided 2, that's 3. That's gonna be 3 actually. Okay, so our mid is a error of 3, that's 5. So it partitions this guy from, this is my 0 and this is my mid, and this is mid plus 1, and this is my high, that is n minus 1, right? Let me call it as a j, so this as an I, for example, I and j, and I start merging them. How I start merging? I put up k here, right? I put up k here, and I just see if this element is lesser than this. Okay. Before this, I actually need I need an array of same size. What I have this time, I and j, I will have the same size. So I'm seeing is 8 lesser than 4? No, 4 is lesser, so I should put 4 here and increment the k to this, and then see is 3 greater than the 8, because I stays at 8 and k stays at 3. Is 3 greater than 8? No, it is not. So who is lesser? 3 is lesser, so put 3 here and increment that, so k will be here. So increment that, 2 will be here and 1 will be here. This k is finished here, and the k has crossed the j. Okay, our loop, which was trying to see this half and this half, which is like while your I is less than or equal to mid and k is less than equal to j, this has this part now false, so it will come out of the while loop, and then that means we have run out of the k. We have k is full, so we have put all these which is on this side on here, that is 8 7 6 and 5. Okay, sorry, not 8 7 6, 4 3 2 1 we put up here, and 8 6 7 5, it will be here. Yeah, definitely. So what happens is, if you see, this one is sorted, this one is also sorted in the descending order, right? So if we have to see in the ascending order, we can see it in a different way. When we are done with this, basically what we have to do is we'll copy back this thing to the same to the actual array, and we'll get this thing as my array 4 3 2 1 8 7 6 5. Now I'm gonna do this sub array and this sub array. Okay, I will do same thing in this and this sub array. Partition and merge. Okay, I will partition this into the 2, that will be 4 3 and 2 1, and this into 2 8 7 and 6 5. Then I merge these two together. How I merge them? First I will put a 2 here, then definitely so 1 here. Okay, I will put 2 here. Yes, 2 here, because k will be here. Okay, let me go down. What's happening to this? Okay, I will, so these two will be merged. 4 and 2 is compared, 2 is lesser, so 2 is copied. Then 4 and 1 is coming, so 1 will put here. Then this k loop is done. We got a 4 3 here, right? This will be like this. Okay, then again these two will be broken into this left and left. Now this will be broken into the 2 and 1, so they will sorted as 1 2 and sorted as 3 4. Then comes back to merge them together, right? So it's 1 2 3 4. Perfect. Similarly on this side we got like 8, 6, 7, 5. It broken into 2 and merged in this fashion. So 7, then 5, okay, then this 6, and then this 8. Now what happens is 8, sorry, it was 8 7 6 5. It was 8 7 6 5. So I got here first 6, no 8 6, k goes 5, then 8 and 7. Now they are internally sorted, right? Like this guy, these two guys will be sorted, like 5 6 and 7 8, and then we merge it 5 6 7 8. On this side we got 1 2 3 4 and merge them together to get it sorted perfectly. So we had a partition, we divide this array and then merge. Actually what we do is we have 8 elements, 1 2 3 4 5 6 7 and 8. It is broken into 4 and 4. Firstly 2 sub arrays, 1 2 3 4 partition step, and 5 6 7 8. Then these quarter plus are broken into the couplets, 1 2 and 3 4, and this one has 5 6 and 7 8. Then this one is broken into, you know, as one individual elements 1, while it comes back, because if the element is only single element we have left in the list, then we will come back, okay, from the recursive calls that we'll see shortly in the program. And now when we've done this, we start merging them together. So if you see the program here, some merge sorts are prototypes, and I'm saying an array of size 50 I, j, n and temp, and then I'm giving some elements, and how many elements I'm putting the n, then I'm scanning these elements, okay. Then before sorting I'm printing them here. Here I'm printing them before sorting. I say asterisk ar plus I, and ar plus I, or you can say ar of I, and here you can say ampersand ar of I, you can say ar of I here, but I get pointer notations as simple as it is. Then I call the merge sort here, right? I send the 0 value and n minus 1, that is 0 and n minus 1, that's copied into the I, and the highest value is copied into the j. Okay, when I come back I will print it again, so that I will say it's a sorted array after this call. Okay, now what I'm doing here is in the merge sort I will do partitions. So I will calculate first the mid, but if I'm saying that I is greater than j, I should return. This is why I should return, because that means I have got only one single element left, because I is not greater than j, means I and j have crossed, that's possible only when we have single element. So I calculate the mid, I plus j divided by 2, and I call the merge sort a and I, and I go to the array a, and I is the 0 and mid value, and that's the left sub half, and after I'm done with that I will do the right sub half. How? I say a, mid plus 1 and j is the endpoint, mid plus 1 is the one element more than mid, that means right half I'm saying. And then when I'm done with partitioning I will merge them together here. Whatever the value of I and j is that moment, I will merge that, guys, using that k variables and all here. Like I got I and j now, whatever the sub array is, I'm sorting, I'm trying to merge at the top level or the bottom level or any level. I am calculating the same array, same size array. B is a temporary array. I got a mid, L and start. I say mid I plus j to a 2, then I say k, I calculate the mid, that I put in the k. So mid plus 1, whatever the mid is, and I will put one element greater than k, one element greater than the mid, and L points to the I. Okay, first, because L is the guy which I will use to initialize my B array. So I'm saying I is less than equal to mid and k is less than equal to j, okay, because what I'm doing here is like this. Like this, if we have an array, okay, if we have this kind of array, for example, and mid is this one, mid plus 1 starts the k from here and up to the j, and I starts from 0 up to the mid, right? And then merge them together, seeing who is lesser will be copied into the array B. As simple as it is. Is it? So I should be less than mid and k should be less than equal to j. Then if a of I is greater than a of k, then b of l, तो जो छोटा है उसे डालो b of l में, दोनों में से, और आगे बढ़ाओ वो वाला इंडेक्स. अगर k वाला साइड ही बड़ा है तो वही डालो, और k आगे बढ़ाओ, i वही रहेगा. और अगर आप i जो है ग्रेटर देन मिड चला गया है, तो जब तक कि, तो इसका मतलब है i वाला फिनिश हो गया है, और हो सकता है के वाला भी फिनिश नहीं हुआ है, तो जो के जे तक नहीं पहुँचेगा तब तक सारे के वाले फेंक दो इसमें। या इसका उल्टा भी हो सकता है कि के वाले ही, जैसे के वाला साइड फिनिश हुआ है और आई वाला साइड अभी बाकी है, तो वो सारे को उठाने हैं और बी में डालने हैं। ओके, और फिर वापस कॉपी करते हैं अपने ए एफ एल में, क्योंकि आप ये बी एफ एल में डाल रहे थे सॉर्ट करके, मर्ज दिस मर्जिंग थिंग्स, dropping the b and we'll copy back to the a. Okay, so that we get the merge element. So if I run it, it's taking so much of time. No problem. And how many elements? I'm saying 6 element, and I'm putting up elements something like that: 6, 5, 4, 3, 2, and 1. So this is my numbers before starting of this, and after starting, because I have done in the descending order, so I could change less than to the greater than there. I will say again 6. This time I get 1, 2, 3, 4, 5, and 6, and get me in the 6, 5, 4, 3, 2, 1 descending order sorting. So this is how merge sort works. So anyways, thanks, yeah.